Thank you so much, Dr. Sidon, for those opening remarks and reminding us all while we're here. So if anyone has not met me, my name is Keely, and I'm an epidemiologist at the Doherty Institute and the WHO Collaborating Centre for AMR. We're working with the Ministry of Health through the Combat AMR project to help continue to strengthen Cambodia's AMR surveillance system. So for today in our network of practice, we're going to be focusing on data cleaning, which no matter what our role is in the surveillance system, whether we're at a hospital as a doctor, a nurse, as a laboratory staff member, or if we're at the national level, being able to look at our data and fix errors is a very important skill to have. Now, throughout this session, if I am speaking too quickly or with my accent, it is too hard to understand, please
This
let
meeting is
myself
being
or
recorded.
Vandrit know. You can write a message in the chat or just message us directly. If you would like something repeated either in English or in Khmer, is also fine too. So please just make sure that you let us know so we can best provide information to you. I'm not sure, Vandrit, if you would like to interpret any of that or if you would like me to proceed.
Please proceed. Sorry, I thought saying something.
All good. Okay. Just to remind everybody, the Surveillance and Data Network of Practice is meant to be a space where we can all come together to build our technical skills to analyze data. It's also somewhere that we can share information and resources across the AMR surveillance sites. So if there's something that your surveillance site does really well that you think other sites in Cambodia could benefit from, this is a great place to share that information with each other, either in these meetings or in the Telegram group that we have together. As we've mentioned, we're going to be focusing today on data cleaning and data management. What will happen in today's session is we will have a brief talk. I have my voice this time, so at the rest. That once we've had the talk on data management and data cleaning, we'll then move to an interactive activity. So if you are in the surveillance and data Telegram group, I have sent through an Excel file earlier today, which has some pretend or fake data that we're going to clean together. If you're dialing in from a computer, you can access that Excel file and you can follow along as we go. But if you've dialed in from a phone, don't worry. I'll be asking you lots of questions as we go, so you're still able to participate even if you're not able to do the Excel activity on your own. Now we're on to our training session. So as Dr. Sidon mentioned, this is our third surveillance and data network of practice meeting, and the training session will be focusing on principles of data management. So that includes how we store our files and how we name our files, some principles to help us do data cleaning. And then once we've gone through that talk, we're going to use those principles to help us clean our pretend Excel data in the Telegram group that's been sent around that I'll also share on the screen. So we will start off with a very quick recap of some data terms and some words you're going to hear me say quite a bit as we go through these sessions. So to start off with, we have our columns, our column names here, which are shown in the pink box. And these are our variables. So if I'm saying columns or variables, I'm talking about the different factors that we record in our AMR data. So this could be characteristics about the patient or the pathogen. We also have our observations, and that is the information that's held about one sample. And that's normally shown in a row. So that would be the individual results for those different factors about a patient or the pathogen. And as we get smaller again, we have these little circles around the specific information, and those are the values Those are the things that we see in an individual cell. So when you hear me talking about information that's in a cell, I'm talking about in these light gray boxes, not what is in a bacteria cell. So let's have a think about some principles for data management. Data management is all about making sure we're setting up our systems for when we're going to clean and analyze our data to make sure that they are easy to use. Data management specifically is the process that we use when we want to set up our data so that it's suitable for analysis. It should be a system. It should be something that we're trying to do routinely. It should be something we're trying to do all the time. What makes good data management? Good data management will help us prevent having errors in our analysis. It will also make sure that we have a single source of truth. We know where there's one trusted data set that we want to analyze. So for Cambodia, when we've got our AMR surveillance data that is hosted in CAMLIS, that is our source of truth. If we have questions about our AMR data, we go to CAMLIS nationally in Cambodia. But if I'm doing analysis at my own laboratory as an AMR Sentinel site or an AMR surveillance site, I need to know where my single source of truth is for my data. It should be something that is in one location that everybody knows, and ideally everybody that needs to can access. The other important thing to keep in mind about data management is that it should be a system that protects the privacy and the confidentiality of the patients that we're storing information about. Only those people who should have access for their work, their routine work, only those people should have access to the data. It shouldn't be available, for instance, to everybody in the hospital when we can help it. So just briefly, I wanted to talk about two principles that we can think about for how we can manage our data well as a surveillance site. So this is imagining that I'm taking data out of either my laboratory information system, CAMLIS, or some other system, and I'm saving it in order to do some fancy analysis. The first thing I should think about is, what am I going to call my file? File names are very important because it helps us find relevant data sources and it helps us keep track of what we're doing. What I suggest each surveillance site does, if you have not already done it, is to establish what's called a naming system and use it every time you're saving a file. And what do I mean by naming system? It should be a short process or formula that your site follows whenever you're saving a file. The file name should contain relevant, what's called metadata, or relevant information about what the file holds. So that could include things like if it's for a particular project, what the project name is. It could be something about the document type. So is it a presentation? Is it an SOP? Or is it a job aid? And it should also make sure that it's including some information that helps us separate what we're looking at. So for instance, using something like a dash or a hyphen in between the important pieces of information is really helpful to make sure we can navigate and identify the right file quickly. What I do suggest, if you can, is to try and include the date of your file in the file name. The way I suggest you do this is you go backwards to how you might normally write the date. You want to do the year first, then the month, and then the day. This is because this is how the computer will keep your records in order. It will try to do them in numerical order. So if we start with the year first, all of our files related to 1 year will appear together, then each month, then each day. This is very helpful to make sure you can find files quickly when you have a folder that's full of many, many files. And the other thing that I would suggest is you try to keep the names short. So in the example I have on the screen, the file names are kept short enough generally that I can see what the file should be holding without having to do too much further review. So this is just one example. Your surveillance site will come up with a system that works for you. But what I suggest you do is you have a chat with each other, think about how you want to save your files and come up with a system that's going to work best for you. And importantly, I suggest that you write it down so that everybody can follow it. Which leads me onto file storage. We have our beautiful naming system, so we know how we're going to create and label each of our files so we can find them. Equally important is where we save the files or where we store them. I encourage you not to save everything to the desktop. It can get very messy very quickly, and it can get very hard to find the file that you need when you have an urgent request. What I do suggest is if you have a shared computer that everyone can access, so for instance, if you are a microbiology lab and there is a computer within your laboratory, this is where you should be trying to save any files that everyone should have shared access to for analysis. If you have a cloud-based system, something that's hosted on the internet, that's even better. But I recognize that if you want multiple people to access a file, we should be trying to save it in a place that most people can access. I do encourage you to use folders to help you organize your files. I generally try to do this by topic and by year. It depends on the file system that will work best for you, but this is a way that helps me find relevant files for the type of work that I'm doing. And what I suggest when you have a local standard operating procedure or a job aid and it's saved on the computer rather than something that's printed out, we write down where it is saved. That's called the file path, which is every folder you have to click on in order to find where the file is saved. And that's an example on the bottom of the screen that I've made up there. Having that as a reference document, like a job aid that you can stick on a wall somewhere, is very helpful to make sure that we're all following the same procedures and job aids when we're doing any data analysis. So that is a very brief overview of some data management principles. We're now going to get on to some principles for data cleaning. So this circle diagram on the right-hand side should look a little bit familiar if you've come to any of our surveillance and data networks or practice meeting before. But this is a surveillance system diagram showing that surveillance is a continuous activity that we routinely do, and it involves each of these 5 steps. Today, we're talking about data cleaning. We've already collected our information. We now need to make sure that it is error-free. No errors allowed. Data cleaning is extremely important to make sure that not only we have no errors, but we have a standard way that we're recording our information so that we can create categories and we can simplify our analysis. And it's also making sure that our data is valid for analysis. What I generally talk about when I talk about data cleaning is principles. There isn't one set way to go about doing data cleaning. It's often project or surveillance system specific. So for instance, for the AMR National Surveillance System in Cambodia, the surveillance system SOP has information about what you would do for data cleaning. And that might be different for if you were taking part in a research project and data needs to be saved in a different way. What I do suggest, no matter what you're doing, whatever project it is, for data cleaning, is that we firstly record what we do. We should write down what we've done as our steps for data cleaning, what order we've done those steps, and any decisions that we've had to make. This helps to make sure that our data cleaning is repeatable, particularly for something like surveillance, where it's a routine activity. We should be able to do the cleaning in the same way each time. We should use a standard process, which is that all of our rows or all of our observations have the same data cleaning applied to them. There should not necessarily be a different approach that's used for different data unless there's a very good reason. So for instance, we might have different data cleaning steps if my data came out of CAMLIS compared to if it came out of a hospital's laboratory information system. And the third thing that we should always do when we do data cleaning is to make sure we use a data dictionary. A data dictionary, which I'll show you an example on the next slide, is a simple table guide what each variable or each column should contain in your data set. It doesn't need to contain a lot of information, but it should contain enough information that I can clean a data set using the instructions or the information in here. Generally, what we include in a data dictionary are things like the name of each variable, the type of data it is. So am I looking at numbers? Am I looking at words? Am I looking at dates? When I have categories or numbers as my variables, I often like to include what should be my valid options. So for instance, age, I would generally suggest the valid ages should not include negative numbers and generally not over the age of 100. And there might be some notes as well to help explain how data has been collected and what might be correct or not. So this example that's up on the screen is also in the Excel file that I've sent through that we're going to go through today for our dummy data set. And this is a very simple data dictionary, but this is a snapshot of the first couple of variables, but we can see in the notes that we have some information, for instance, about how the date should be formatted. So going from that year, month, then day. We have some information about my potential options when I have a categorical variable or a variable where I select one category. And I have some information about IDs. We'll get into this a little bit when we go through the exercise, but for instance, a sample, we should only have one sample ID, but one patient could have multiple samples taken. So a patient ID might repeat. And that's been made clear in the data dictionary. So for data cleaning, the 3 things we need to remember: record what you do, make sure we do a standard process, and where you can, use a data dictionary to help guide you through your data cleaning. I now want to hear from you. It's time for a little bit of an interactive exercise using this Menti. So you can either scan the QR code that's on the screen, or you can go to menti.com and you can enter in this 8 digits here. And this is hopefully loading for you. What I would like to hear from you are what are some of the things that we should check before we analyze our data? What are some of the things that we should do when we're doing data cleaning? And I look like I'm still waiting for anybody to join. So if someone can just please double check if you can join. Oh, I can see I've got a 0 now. That's good. I've got some people that have joined. Please take your time. And if you want, you can write in Khmer or in English. I'll ask Vandrix to translate anything that's in Khmer. If you choose to write in another language again, we might be in a bit of trouble. So please try to keep your answers to English or Khmer. Yes, we should be cleaning our data. Let's think about what sort of things we could check when we need to clean it. We should check the source of the data. That's very good. We should be checking where it's coming from. It's very important to know where it's coming from. That can tell me a little bit about how much I trust it. Duplicates, that's an excellent answer. If there's a record that's been repeated, I realized you can't see the answers. There we go, hang on. We should check the variables, yes. What else could we check? The formatting, that is also very important. Sometimes our dates in particular get formatted the wrong way in something like Excel. So the format of our data is very important. The type of data that I have is also very important. It's very important to know if I should be looking at words, if I should be looking at categories, or if I should be looking at numbers. Spelling errors is very important, as well as making sure that we've got full information. So we're checking, for instance, if we have missing data and what we're going to do. I'll give you one more minute to see if anyone else has an idea. Anything else that we should check? If I have numbers data, what are some of the things that I should check? Yes, making sure our groups are making sense as well. So if I have grouped data, I should be using the correct label for that group. All right, we've got many good ideas. I'm glad to see that we're all thinking about the types of things we should do to clean our data. Oh, and making sure that we have got our categorical data correct. And spelling errors. Spelling errors when we are entering something where we're typing it. Humans make a lot of mistakes. So we want to make sure that we're spelling everything the same way. Duplicate patient IDs are also important for us to check, particularly for something like the AMR surveillance system, where we have got guidelines on whether we should be including a patient's record multiple times in our data set for different pathogens or not. Oh, look at this. Brilliant thinking, everybody. We've got very good answers and glad to see that missing data's also made it on there. So I might just let us stop for a minute and get back into the presentation. So well done. I'm very glad to see that you've come up with almost everything that I was going to suggest we need to check in our data set when we're doing some data cleaning. Hopefully we can get that arrow to go to the next one. So these are 6 different areas that we should be thinking about when we're doing data cleaning. The first one, which we all came up with, is duplicates. Each sample should have its own line. For some of our data, particularly AMR data, it might be that every antibiotic I test has its own line. We need to think about the lowest level of information, the finest level of detail, and that should all be on its own line. Sometimes it is okay for a patient to have multiple samples. Sometimes it is okay for a patient ID to repeat. But this depends on what principles we've decided we're going to do for data cleaning and what's in our written instructions. That's why it's always important to write down what we're going to do with our data cleaning. Another thing to check for are errors. Sometimes when we need to enter data, particularly if we need to enter data manually, so if I need to type out a lot of things, we'll make mistakes. My spelling, for instance, is not very good. I often spell words wrong. So when I'm cleaning data, I need to go through and check that I'm spelling the word the same way the whole time if I don't have a set category like a tick box that I can choose. We also need to make sure that our categories match what's in our data dictionary and to check that we maybe don't have any negative values when we have numbers when we shouldn't have a negative value. Another thing that we should check when we're looking at our data for analysis is if if each of our observations or our rows meet our case definition. So case definitions or laboratory definitions are very important criteria to confirm which samples we should or should not include in an analysis. It's very important for us to be clear who we're counting and how we've decided who we're counting. So that might be making sure that when we're looking, for instance, at a carbapenemase producing organism, we're checking what antibiotics they've been tested for, so any carbapenem, and we might be really clear about how we're testing what's resistant. So which guidelines are we using? We're using CLSI guidelines, but what year are we using? Things like that makes it very clear as a set of criteria who should be included and who should not. And we can use that sometimes to make sure that we're only including rows that are relevant. Missing data is an interesting one. Sometimes we can't do anything about our missing data. It might be too late to go back and collect more information. So we'll need to come up with a plan for how we're going to include missing information or missing data in our analysis and how we will report it. Sometimes it might not be important to show the missing data, but it's often a really good thing to show the proportion of your results that might have missing data. It helps us to make a good decision and come up with good conclusions when we look at the data, when we understand how much is missing. We work in the real world in public health, and I have never seen a public health data set that's 100% complete. So it's normal to have some level of missing data. We just need to come up with a plan for how we're going to include it in our analysis. Sometimes we might be able to go back and check. Sometimes it can be a simple way, particularly if we have an electronic system at our hospital, but not always. Something I do also encourage that we check, particularly when I have number values, is that my numbers should be valid. They should make sense for the type of variable that we're looking at. So the example I often think about is age. If I see a negative age, I should be a little concerned because nobody is aged a negative number. Likewise, if I see a number that's over 100, I'll be a little bit skeptical as well. So we can think about our data sets, particularly our number data sets, and what might be a valid range. So when you're thinking about something like the zone diameter or MIC values, it's often helpful to know what is your minimum, your maximum, or what are your set values, and to check that your data matches that. And the last thing, which we did also raise in that Menti exercise, is our data formatting. And I do suggest that we pay a particular attention to dates. Excel treats dates very differently. Sometimes it will show you as a number. Sometimes it will change the order. So it might show month, day, year, for instance. What I suggest we do is when we're formatting is we have our one set way that we're going to agree on for the analysis to format our data or to format our dates in particular. And as I was suggesting, start with the year, then go to the month, then go to the day. But you can decide what's going to work best in your system. The reason I suggest year, month, day is it's harder to confuse which one is the month and which one is the day. So that's the end of the talk. This is just a very quick summary of what we've discussed in this session, which is around, it should say data cleaning at the top there. But the point that we should be, this slide didn't update. My apologies that this is not updated, but the key things that we should take away from data cleaning is that it is a standard process. There's no one way to do it, but the way that is going to work is the one where you write down what you're going to do. It's a standard way across your whole data, and ideally you use a data dictionary. There are many different things that we should check for when we're looking at a data set, and we're going to practice those now. But before we go into practicing that with our interactive exercise, does anyone have any questions about data cleaning or about data management? I'll just pause there And Vandrit, you might need to help me out if there are questions or if anyone would like something repeated or clarified.
Okay.
Are we all okay?
ครูมีសំណួរអីទេអូខេ I saw a comment from Bongretsa. They explain again about the data outside set range.
Okay, so thank you for your comment, Rexa. So what we're clarifying here is thinking about if our data makes sense and is it outside of a set range. So this is something that might be specific, particularly for our numeric data, our numbers data. We need to think about if our number data makes sense with what we know about that variable. So I think about age as the example. When we're born, our age is 0. And if we're lucky, we can live up to about 100. 100. If I see an age in my age column that's -2, it doesn't feel like it's within that set range of what an age should be. So that might be an invalid data variable. We generally want to set that range about what makes sense as a number variable, what's going to be a valid result before we start doing the data cleaning, before we start doing the analysis as well. This helps us to make sure that our numbers don't have any errors in them. So for instance, an age of -2 would be an error. Something that also we might use for having a set range could be body temperature. If somebody's body temperature is 10 degrees, that doesn't seem likely. That doesn't make biological sense. So we would need to think about what are the valid numbers that we would expect somebody's body temperature to be. So what would be the lowest number we'd expect? What would be the highest number we'd expect? I don't know the numbers off the top of my head as I'm not a medical doctor, but generally we want to think about what those numbers are ahead of time and check if each of my rows is within that range. A final example might be dates in an outbreak investigation. I might have a date at the start of my outbreak investigation, at the start of my case definition, and then I might have the day that I've ended my investigation. And I might be using the specimen collection date for that start and that end. And I would want to check that all of my specimen collection dates in my data set are within this range. If I have a date that's earlier or later, that's outside of my set range, so I would exclude them from the analysis, or I would need to go back and double check that result. So I hope that those examples are helpful, Rexa. If you can let us know if that has answered your question. Very happy for you to respond in the chat. Yeah, as the criteria set. So the aim is you want to set criteria first, then check your answers, and then work out a strategy what to do when you have numbers or dates that are outside that criteria. That's exactly right. Okay, no worries. Thank you, Rexa. Afgun Rexa. Or Bong Rexa, pardon me. Does anyone else have any other questions?
មានលោកគ្រូណាមានសំណួរទៀតទេគ្រូចាស់នៅសំណួរអីទេបង
មិញអត់តកន្លែង missing data នឹងយើងចង់សំដៅលើថា data ត្រូវតែមានពេញទាំងអស់ឬក៏មិន
We would like to clarify on the missing data. Is it do we need to have the complete data or what?
Yeah, that's a very good question. Do I need 100% complete data to do analysis? I would say no. There's no set threshold though, no set percentage that I would say you can have X% of your data missing for it to still be valid. This is something that is on a case-by-case basis. Ideally, we're aiming for 100% complete data, but often we can't get 100% complete data. patients don't remember information, a laboratory test wasn't conducted, and that's normal. That's okay. What I do suggest when we're doing an analysis is that we report how many are missing. So for instance, if I have an age variable and I have 2 records that are missing, I might have a table or a graph that shows my age groups. And at the bottom, I might make a note to say 2 values were excluded because they were missing an age, no age was recorded. So you can analyze data even when there are some things missing. We should try to have as much complete as possible, and we should try to minimize the amount of missing data we have. But because we're working in routine and rapid analysis in public health, we often do have some missing data. Vandrit, are you okay to interpret? You can do the short version of that. That's also fine.
Sorry, Kelly, I missed.
Okay, so the short version, you can have missing data. That is okay. We should aim to have 100% complete data. But if we have got something missing and we're doing an analysis, we should generally put a note about how many and the percentage of the total records that are missing that information that we're analyzing.
Okay. អញ្ចឹងសម្រាប់តកតងមួយកន្លែងហ្នឹងគឺយើងឃើញថាយើងអត់ចាំបាច់ complete វា 100% ទេយើងនៅតែអាចមាន missing វាបានប៉ុន្តែការអ្វីដែលយើង miss ហ្នឹងគឺយើងត្រូវ take note ហើយចំនួនប្រមាណយើងត្រូវកត់ត្រាវាទុកអញ្ចឹងណាដើម្បីយើងបង្ហាញថាពេលដែលយើងធ្វើការវិភាគហើយយើងបង្ហាញគេថាតើអ្វីដែលយើងបាន miss ហើយចំនួនប្រមាណ total អីចឹងទៅដើម្បីឲ្យគេបានដឹងអ្នកឲ្យគេមកអាន paper យើងឬក៏មើល slide របស់យើងឲ្យគេបានយល់បានដឹងអញ្ចឹងណាបាទ
And then I can see that we also have a question from Rexa about whether we should take out the missing data before we do an analysis. The answer is unsatisfying. The answer is it will depend. Every time we do a data analysis for a project, it is slightly different. Every time we do data cleaning, it is slightly different. So there might be some times that, yes, you will take out the missing data before you do the analysis. And there'll be some times where you keep the missing data in your analysis. Either way is fine, so long as we're clear about what we're doing. And particularly if you take out the missing data before you do the analysis, that you note that at the start of your analysis and you mention how many records were removed because there was missing data. I'm not sure, Vandrith, if you would like to interpret that, but yes, Rexa says okay.
Yeah. អញ្ចឹងការ check ទិន្នន័យ missing ហ្នឹងមុនពេលឬក៏កំឡុងពេលវិភាគទិន្នន័យហ្នឹងគឺមួយណាក៏បានដែរអាចធ្វើសនាគ្នាក៏បានឬក៏យើងអាច check មុនហើយយើង take note ថាតើ missing data របស់យើងហ្នឹងវាមាន miss ប្រមាណអញ្ចឹងណាហើយដល់ចឹងក្នុងករណីខ្លះគឺយើងអាចធ្វើការវិភាគទៅគឺយើងអាច find out ថាតើ data missing ហ្នឹងមានគេខ្លះប៉ុន្តែយើងក៏ take note ដែរកន្លែងហ្នឹង
Okay. Does anyone have any other questions? Or are we okay? You don't have to have questions. That's okay.
អ្នកគឺ theory expert អញ្ចឹងក៏អត់សំដៅ
I don't know about expert, but I like to share my knowledge. Yes. Okay, thank you for clarifying, Seng Hui, about not having questions. So we have 30 minutes left in our meeting, and now we're going to get onto our interactive activity. So if you have dialed in on a computer and you go to the Telegram group, you should be able to download the Excel file that we're going to use.
Okay, ចឹងលោកគ្រូអ្នកគ្រូ download ទិន្នន័យនៅក្នុង Excel file ដែលយើងបានផ្ញើជូននៅក្នុង group ហ្នឹងណា លោកគ្រូអាច download ទុកសិនមក
And it's okay if you do not want to follow along or do the exercise yourself. I will be sharing my screen so you can watch, and this is recorded. So you can come back and watch this again as a reference.
ហើយមួយវិញទៀតបើលោកគ្រូអ្នកគ្រូអត់ចង់ធ្វើនៅលើកុំព្យូទ័រខ្លួនឯងទេអាចមើលនៅតាម Zoom នេះគាត់នឹង show slide ទាក់ទងមួយទិន្នន័យនឹងដែរហើយលោកគ្រូអាចមើលទៅហើយអាចយកមើលវាពេលក្រោយដោយសារយើងមាន record ចឹងណាយើងនឹង share ជូនអរគុណ
Alrighty. So, as a reminder, in the surveillance and data network of practice, we have a scenario that we're going to follow through each of our meetings. In this scenario, we all work together at one hospital. We all work together at the surveillance and data hospital. We want to understand a bit more about a new emerging AMR pathogen, which is called Penulticin-resistant Wolf Factor Nosocomia, or called prawn for short.
អូខេចឹងចង់ជម្រាបលោកគ្រូអ្នកគ្រូថាយើងនឹងប្រើ scenario នេះរហូតដល់យើង training ចប់session របស់យើងទាំងអស់ដែលលោកគ្រូអ្នកគ្រូត្រូវគិតថាយើងកំពុងធ្វើការនៅក្នុងមន្ទីរពេទ្យតែមួយហើយយើងនឹងធ្វើវិភាគទិន្នន័យដើម្បីមើលថាតើមាន AMR pathogen ថ្មីហ្នឹងដែលមានឈ្មោះថា Prawn ហ្នឹងនេះគឺឈ្មោះយើងបច្ឆៅទេអញ្ចឹងលោកគ្រូអ្នកគ្រូមិនឆ្ងល់ថាមិនក៏មានឈ្មោះអីចម្លែកមែនតែនេះយើងគាត់តែដាក់វាដើម្បីឲ្យយើងយកទៅវិភាគអីចឹងណាជា fail គេអរគុណ
Yeah, so it's made up. It's not real. It's an imaginary pathogen. So you don't need to know anything about prawn. But what we're just keeping in mind from our scenario last time, we got asked by our hospital director to answer 3 questions about the prawn pathogen. The first one is how many patients have prawn? The second is what is the clinical outcomes of patients with prawn? And then third is, do we think that there's transmission of prawn happening at our surveillance and data hospital? What we agreed in our session last time was that we're going to need to collect more than just laboratory information.
អូខេអញ្ចឹងនេះគឺជាសំណួរដែលយើងសួរទៅមើលដែលយើងត្រូវរកនៅក្នុងទិន្នន័យរបស់យើងហើយនៅក្នុងហ្នឹងតើប្រវត្តិទាំងអស់ដែលយើងមានហ្នឹងប្រហែលនៅក្នុងអ្វីដែលយើងបានប្រមូលទិន្នន័យហ្នឹងហើយអ្នកជំងឺប្រហែលអ្នកដែលមាន infection ទៅលើជាមួយនឹងប្រវត្តិហ្នឹងដែលយើងឃើញពី clinical outcome របស់យើងហើយមួយវិញទៀតតើប្រវត្តិហ្នឹងមាន transmission អត់នៅក្នុងទីពេទ្យទៅតាមទិន្នន័យ surveillance data របស់យើងហ្នឹងហើយអ្វីដែលយើងបានជួបគ្នាតាំងពីសប្តាហ៍សុំទោសតាំងពីខែមុនគឺយើងបានវិភាគទិន្នន័យមួយចំនួនហើយយើងត្រូវការទិន្នន័យមួយចំនួនទៀតមកពីខាង labo អញ្ចឹងណាអ្វីដែលខាងក្រុមទីពេទ្យគាត់បាន suggest បាទ
So last time we agreed we needed to collect some clinical information. And we've done that. That's fantastic. We've got this and we've combined our laboratory and our clinical data into the one Excel file, which is what I've sent to you all. Before we can do any analysis, we're going to need to check that our data is correct. So we're going to need to clean our data together. For those who would like to, you can open up the Excel and you can follow along. But if not, that's fine. I'm going to be sharing my screen and we can watch together how we're going to clean our data set.
អូខេចឹងឥឡូវយើងបានទិន្នន័យរបស់យើងដែលលោកគ្រូត្រូវការតាំងពី clinical data បូកជាមួយនឹងទិន្នន័យ laboratory ដើម្បីរកមើលថាតើប្រវត្តិ case របស់យើងហ្នឹងនៅក្នុងឆ្នាំ2025ហ្នឹងមានប្រមាណអីប្រមាណចឹងទៅហើយមួយវិញទៀតលោកគ្រូនឹងត្រូវធ្វើការ check ថាទិន្នន័យរបស់យើងវាត្រឹមត្រូវអត់ហើយធ្វើការ clean ទិន្នន័យហើយលោកគ្រូអាចធ្វើនៅលើ laptop ខ្លួនឯងក៏បានឬក៏លោកគ្រូមើលនៅលើ Tele ដែលគាត់ធ្វើឲ្យក៏បានដែរ
Okay, so we hopefully are now seeing an Excel file on the screen. Vandrith, if you can give me a thumbs up if you can see it.
Yeah, we can see it now.
Okay, fantastic. Woo, I've lost my mouse. Okay, this is our data. We have a lot going on here. So what I suggest we're going to do before we start looking at each of the individual variables in our raw data tab, we have a handy little data dictionary. As the data cleaning fairy came and visited and gave us a little data dictionary. Our data contains some information about the hospital, the sample ID and the patient ID. So we're able to identify individual records. It has some demographic information and then some information about the organism that we've found. So the sample type that we've used to test, what organism did we find, the different antibiotics that we've tested. And then a bit later, we also have some information about the clinical outcomes and the wards that patients were admitted to during their stay. If you have the file on your computer, you can scan through and see that some of these we've been really clear about what options we should have. So for instance, in our province, there should only be 3 provinces in our data set. We have the nurse province, the lab province, and the doctor province. If I see another province, then that shouldn't be in my data set, for instance. That's what this data dictionary is showing me here, what should be included in my data. So when we're looking at our data set and we're wanting to clean it, one of the best things that I suggest we use in Excel lives in the home ribbon up here. And under this editing menu, there's the sort and filter button. The filter is this funnel shape. We're going to turn the filters on. I know that the filters are on because I now see these little gray boxes have appeared next to each of my variables or each of my column headings. And the good thing with the filter is that I can click on that arrow and I can see how many options I have. So for instance, at the Surveillance and Data Hospital, I'm glad to see that all of my records are only for the Surveillance and Data Hospital. That's a good start. But maybe I'm coming over here to the sex variable. I should only have 2 answers. I should have male, which is M, and I should have female, which is S. And oh no, I have 3 options here. I have male, female, and a double F. That's not right. That shouldn't be the case. Does anyone have any ideas on how I can clean this data of this double F? How can I get rid of it?
ចឹងលោកគ្រូអ្នកគ្រូមាន idea អីចង់ចែករំលែកពេលដែលយើងឃើញទិន្នន័យរបស់យើងមាន F ផង M ផង double F ទៀតចឹងដើម្បី clean វាតើលោកគ្រូអ្នកគ្រូគួរធ្វើម៉េចអាចផ្ដល់ជាយោបល់បែបនេះ
ទុកអា double S ហ្នឹងទៅហើយកែហ្នឹងឲ្យត្រូវវិញ បងចាំបានន័យថា select យកតែ double S ហើយយើងកែវាទៅជា F វិញត្រូវអត់ហ្នឹងពេល double S វាជា duplicate ដែលយើងវាយច្រឡំអីចឹង Okay. So Dr. Sukchan would like to filter and select only double S, and then we can correct it.
Yeah, so what I've done here is I clicked on that little grey box to open the filter. All of these were selected before. I'm going to unselect them and only select the ones that I want to clean and click OK. Ooh, that's a lot. That's a lot of records. I could manually go through each one and change them. That will take a while. I could also copy one that's correctly formatted and then select one that's incorrectly formatted and paste. But I can't necessarily select all of these because I have a filter on. And you can see that when I've selected all of these, the numbers on the left here that told me what row I'm looking at are lighting up, and they're not each individual row. Sometimes we're skipping over some rows. So those will be the ones that are formatted correctly, the males and the females. So I don't want to accidentally change male records to female. So I have a third thing that I can do. I'm going to turn the filter off, and I've selected this whole row here by clicking on the letter at the top here, the E. And what I'm going to do is go back over to this editing menu in the home ribbon to find and select, and we're going to replace. If you're really fancy and you're on a Windows computer, the keyboard shortcut is Control-H. I'm not 100% certain, but if you're on a Mac, it's probably Command-H. And you should see a pop-up window appear. So hopefully you can see my pop-up window. What we're going to do is we're going to, in these two boxes, provide instructions on how we're going to do some data cleaning. The first thing is, what is it I'm trying to find? What's the error? The error is the double F. What do I want to replace it with? I want to replace it with a single F. The reason I'm choosing to do that is because it's likely that the error is because somebody's accidentally hit the F twice. I can make an educated guess as to what the data should be, so I can do that for my cleaning. The last thing I want to do is there's this box down the bottom here that says match entire cell contents. And I'm going to click that one. So it will only change cells where the only thing inside them is a double F. So it won't change anything that has a double F written anywhere else. We can find how many records there are by hitting that Find All button, and it shows me where every single one is. Everything's in column E, which makes me very happy. I'm not going to accidentally change any data anywhere else. And when I'm happy with that, I can replace all. And I will get a pop-up that tells me how many have been updated. So in this case, I have 31 records that have changed. So now, when I have my filter on the sex variable, I only have two options. Yay! I'm happy with that now. I've gotten rid of my error, and I've done that without having to manually change every single one. So that's good. Another thing that we're going to check is the sample type. And oh no, I have two different ways that blood has been written. Somebody has misspelt blood. Somebody misspelt blood and accidentally put 3 O's in there instead of 2. Now, who can remember the way that I can replace my values quickly without having to go through and change each one? Does anyone remember what that function was called, or where it lives in the home ribbon? You can write it in the chat if you're shy. I'll give you a couple more seconds. How am I going to replace this error? I've got an error, and I'm just going to copy it.
This meeting is being recorded.
And we do is we want to see what those duplicates are before we try to remove them. When we're wanting to check for duplicates, we should think about what variables are important for us to check for duplicates. Does it need to be an exact duplicate across every single row for me to remove it? Or is it only a few of the columns that I'm interested in? Like maybe it's the sample ID and the age of the sex, for instance. Just going to show you one example of how we can check for duplicates. And I'm going to use the sample ID. Why am I using this sample ID? I'm using sample ID because this should be unique for every sample in my database. My antibiotics are actually in here as columns. So I don't need to think about how sample ID should be repeated 5 times for the 5 antibiotics. I should only just be checking in my column here for the sample ID. If there's a duplicate, we need to think about whether we want to remove one. I'm going to select my column. And I've done that again by clicking the letter at the start, and that selects the entire column. One of the ways that we can check if we have duplicates in a nice visual way is, again, in this home ribbon. And I can come over here to styles. There's a section called conditional formatting, and it normally has this icon where the bars are different colors. When I open up this menu, there's lots of options. I just want you to go to the first one, and right at the bottom here, we have a handy dandy one called duplicate values. I can click on this and it will tell me how, it'll ask me, sorry, how I want them to be formatted. So I want to check duplicates, or I can check the unique values. In this case, I want to find the duplicates, and I can choose how I want them to show up. I'm going to go with that light red with the dark red text because that will be very visible. Now, I could scroll down, but sometimes my data set's too big for that. I can go over to where I have my filter, and then I can actually have a filter by color. So because I now have some cells colored in, I have an option. If I clicked this one, for instance, over here with patient ID, I can't filter by color because everything's the same color. I can do that for sample ID and say I want to check this light red. Oh no! Oh no, I have a duplicate. I have one record that is a duplicate sample ID. I can see that it's the same age, the same sex, the same province, the same sample collection date, and that's one that I would generally use to say that, yes, this is a true duplicate. And I'm just going across to check that all my information is duplicated. Oh no. What I'm going to do now, I'm just going to remove this filter so we can see the whole data set. Because I'm satisfied that that's a duplicate, I can select that whole row. In this case, I'm going to select row 67. I can right click and I'm going to delete. And that row will disappear. Oh, no, hang on. Yep, that was the right one. Pardon me. I just undid just to double check I had the right sample ID and that I didn't lose both of them. But you can see that sample 65 here, that's in row 66, it's now lost its color because it's no longer a duplicate value. So that's good. We now don't have any duplicates in our data set. We don't have duplicates and we've worked out how to do find and replace. We're now going to have a look at age, because age is one of those variables that's a number. In our data dictionary, we have the patient's age in years. And we've already decided what our valid set range is, which is 0 to 100. If the number 0 right through to 100 appears, then I'm satisfied that that age is real. But if it's a number that's outside of that range, I'm going to be a little bit concerned, and we need to think about how we're going to do some data cleaning. And again, we're just going to use our filter because this will summarize all of the ages in our data set. And oh no, I can already see something that doesn't look quite right. I'm going to unselect everything, so all of the boxes are now not ticked, and only select those that I think might be an error. So I have a -57. And if I scroll down, oh no, I have someone that's 279. That's unlikely. If it's real, I want to talk to them about how to live such a long life. But now I have these two records here that have invalid ages, ages that don't make sense. And there isn't really a set way about what I should do here. When I was doing the find and replace, we had categorical variables. We had categories that we knew we could use that would make sense for what we were going to do. But that's maybe not the case this time. What we're going to do now is we're going to have to vote. We're going to have to come up with a plan. So you've got to get your Mentimeter out again. And as a group, we're going to decide what we're going to do for our ages. We've got one person that's aged 297. And I've got another person that's aged -57. We as a group have to decide what we're going to do. And I've given us three options. We can either remove those rows. We could remove the two rows that have the invalid ages. Or we could just delete the information that's in the age column. So there'll be blank cells. There'll be some missing data. Or our third option is that we can edit the age with our best guess. So if you can, let's open up the Mentimeter and let's vote together on how we're going to do our data cleaning for the age column. I would like somebody to vote. Okay, so we've got one vote for deleting the rows. You've got 2 minutes, no, maybe 1 minute to get your vote in. I would like to have at least 5 people vote. Oh no, we're all split. So we're going to need an odd number of people. Okay, we've got 2 people that say we should delete the age in the cell. And again, all of these answers are valid. All of these answers could be right. There's no wrong answer for how to do this. There's just the way that we agree to do it and that we would consistently do. So we do the same thing for both errors. So at the moment, we have 3 people that have suggested that we're going to delete the age in the cell. Hopefully we're happy with that. In the interest of time, we're going to move on. And we're now going to do that, what we've decided here. What we're going to do is we're going to delete the age. Sorry, I saw that somebody else voted to make sure that we could edit the age, but we're going to go with deleting the age for this one. Once I share the screen correctly again, please bear with me. I feel very old when I can't remember how to share the screen. So looking at our 2 records here, we've agreed as a group that we're going to delete them and we're going to just have some missing data, and that's okay. If I had something like the date of birth of the patient and I have the sample collection date, I could probably calculate it and I could probably check what the age should be, and then I could edit it with my best guess. For something like the negative number is probably okay, but that 279, they could be any combination of those. Do my best guess there. But that's great. We've cleaned up our age variable. Yay, that's nice and clean. I do want to check our organism though. Everybody should be this Wolfbachter nosocomia in this analysis that we're going to do, because that's what our hospital director wants us to look at. We've still got our filters on. I'm going to click my arrow here and oh no, I have 2 different organisms in my report. I'm going to unselect the nosocomias just to see how many of these HAI acquirees I have. And I have 4 of them. Okay, so it's not a lot of my data. That's reassuring. But again, there isn't really a set way about how we should handle this for our analysis. So we're going to vote again as a group. What are we going to do? How should we clean the rows that have the wrong organism in them? So that hopefully has switched over on your Mentimeter on your device. And we should hopefully now see on the screen. What should we do to clean our rows for the wrong organism? I have 4 rows that are the wrong organism. Should I delete the rows? So I remove those 4 rows from my data. Should I delete the organism in the cell so it's blank? Or should I be editing what is in that cell so that it's Nosocomium? Okay, again, I want to get to 5 votes before we make a decision. Okay, we got to 5 votes, or at least we got 7 votes. Good job, everybody. What we voted to do here is to change the organism. What I would suggest is if in the real world, you would want to be very certain that that is correct to do. Because this is a made-up pathogen, we're going to say that that's valid for us to do. What I would normally recommend doing in the real world is one of the first 2 options is deleting those rows or deleting what's in the cell. But this is also okay if we have a valid reason and we write down why we do it. So we're going to replace the information in here. Somebody that is not Senghui has to tell me, what do I do? What is the function in Excel? Where do I go to find to replace the value in the cells where it says HAI acquiree? How do I replace it? What am I going to do?
We call up a dictionary.
Yeah, no, that's great. But how do I go through the process? Should I write it out for each of them? Or is there a fast way that I can do it? Command H. Senghui, you weren't meant to answer the question. You were meant to let somebody else answer. But yes, you can use Control H or Command H to find and replace. So I'm going to select them all. Remember, find and replace lives in the home ribbon. And you can go to find and select the magnifying glass. And what we're going to do, delete everything that's already in there. What are we finding? What's the error? Our error is this HAI acquiree. We're going to copy, woo. And then we're going to replace it with the correct value. We should double check again that we're checking the whole cell content, so it's not going to edit something where it might be elsewhere in the text. We're going to find all our errors. We knew that we had 4 records. And I only have 4 on here, which is good. So it's not appearing in any of my other variables. And when I'm happy, I replace them all. Hooray! So hopefully that's the case here. Now, I just wanted to double check that I was actually sharing the for that bit there.
This meeting is being recorded.
All of this is going to change, which is only in our 4 rows that we know about. So that's great. And when we're happy, we replace all. Hooray! That's fantastic. The last thing that I want us to check for our data cleaning is the formatting of our data. And we're going to focus on dates because Excel often gets dates. Date. And I have the date of death if a patient has died. So I'm going to have a look at those individually. So I have my sample collection date here. And that is formatted as year, month, day, and they're all formatted correctly. So I can see that Excel recognizes it's a date, it's starting off with a year and then showing each month. I also have my date of death. There are some blank here, so blank cells, that's fine because most of my patients have not died. So those should be blank. When I'm looking at the dates, again, it's recognizing it's a date because I've got this year, then the months. But oh no, the hospital admission date is a number. What is these numbers? Why is it 46,023? What does that mean? Excel does this because of the way that it needs to record what a date is. Excel is taking the number of days from the 1st of January, I believe it's 1970. So the 1st of January 1970 would be number 1, and then we go up for each day. That's why it's 46,000. The reason it does that is that's just how Excel is able to store the data so that it works. But that's not how our brains work. Our brains need to see this as a date. We can format this again by selecting the whole column in the home ribbon, and we go over to this number menu. And you can see that there's some symbols here. So if this was meant to be a percentage, I could use the percentage button. If it was meant to be in dollars, I could use the dollar button. But what I want to do is to format this as a date. So I go to this drop-down menu. There's lots of options. The one that I'm going to select to start off with is this short date. So I don't care what day of the week it was, I care what the day, the month, and the year are. And I can see that all of my weird numbers are now formatted as dates. But this isn't exactly the format I want. The format that we have in our data dictionary is that we want it to be by year, month, and day. We can do that by selecting the whole column again, going to our drop-down menu, and going down to this more number formats. And we can see that there's lots of different ways that we can choose to format our date. There'll be the way that makes sense for your team, the way that makes sense for your Sentinel site, the way that makes sense for doing national reporting. But what we're going to do to follow our data dictionary is just scroll down this menu, and I can see this one here goes year, month, and day. And I click OK. And now my date's formatted correctly. Hooray! So those were all of the things that we wanted to check in our data set. I promise you the rest of the data set is clean. You're going to have to trust the data cleaning fairy. The most important thing we need to do now is to make sure that we save our file. In my case, I'm pressing Control S to save. Save what you do in case the file decides to close on you or die. Alrighty, that was our interactive exercise. You survived. Well done, everyone. I'm just trying to find where my presentation went. And we should now be seeing our update. So in summary, what did we do? We managed to remove our duplicates and we used some conditional formatting to help us find those duplicates before we removed them. We also fixed the formatting of some of our categorical variables by using the find and replace function. We fixed the date formatting so that it's showing as a date and not as a random number, or it feels like a random number. And we also, as a team, reviewed and made decisions about what to do for our invalid ages and our invalid pathogens. So well done, everybody. Good job. So we now have a clean data set. That's fantastic. If you've been doing this on your computer, you have a clean data set ready to go. I will also share a clean data set in our Telegram group. But the hospital director is now keen for an update. They want to have the answers to their 3 questions. So next time, we're going to have to prepare a short analysis to help answer our hospital director's questions. So next time, we're going to practice doing some simple data analysis using pivot tables and pivot charts so we can solve our prawn problem. That's the end of our session, and I know that we've been going for 90 minutes. That was a very long meeting, everybody, so well done. I'm happy to stay on if anybody has any additional questions about data cleaning or data management. I also recognise that you're all very busy people and you have other jobs, so if you need to go, that's perfectly fine too. If you have questions and you don't want to ask them now, or if you come up with questions later, that's what the Telegram group is for. You can send in your questions and I'll answer them. If you don't feel confident sharing them with the whole group, you can also message me individually on Telegram. And I can share the results anonymously with the group, so you won't be identified if you ask a question that I think the whole group should hear the answer to. Because I recognise that we're really close to time, Bandrix, did you want to ask if they had questions, or should I get to closing remarks?
Yeah, côមានសំណួរអីទេមុននឹងបញ្ចប់ហើយលោកគ្រូអាចតាក់ទងមួយ Kelly បានបើសិនក្នុងករណីមានសំណួរអីផ្សេងៗអញ្ចឹងbecause Dr. Sidon is still here, maybe we need to close and okay, so Kelly, you can close.
All right. Well, thank you very much, everybody. I hope that everyone learnt something today. I certainly learnt that I need to make sure I'm sharing the correct screen when I'm instructing. So hopefully next time I won't make that error. But hopefully what we've covered today will help you with cleaning your own data sets when you want to do your own hospital level analysis or when you're trying to do some kind of reporting. We will hopefully meet together again in July so we can continue our surveillance and data network of practice. But please do ask questions in the Telegram group if you have any, or if you have anything you would like to share that you think would be useful for the rest of the group. Please do keep using the Telegram group. With that, I think we can close the meeting. Akun, Lokru Nekru for participating today.
មានដែលបានចូលរួមថ្ងៃនេះអញ្ចឹងសូមអរគុណច្រើនហើយយើងសូមបញ្ចប់ការប្រជុំរបស់យើង training របស់យើងខាងលើនេះ
And goodbye, everybody.
Bye.
Thank you so much,
Goodbye.
everyone. Akun.
The recording has stopped.